Hey there, Ken here from NoBrainer. It's Marathon Sunday in Warsaw and in Berlin for that matter, and I'm taking a break supporting some of my friends who are actually racing both marathons to help out one of my students who had a little math exercise issue in his studies right before taking the exam this week. So let's get right into it. Let me show you the problem. Okay, so this exercise comes out of the official guide's Math GMAT supplement, and it's actually exercise 175 if you want to check it out in the 2017 book. And it's a word problem that's a little involved and has some words that some of my non-native English speakers actually have had some trouble with. Let's read it together. A square wooden plaque has a square brass inlay in the center, leaving a wooden strip of uniform width around the brass square. If the ratio of the brass area to the wooden area is 25 to 39, which of the following could be the width in inches of the wooden strip? 1 inch, 3 inches, and 4 inches are the three choices we're given. And of course, it's multiple choice. The answer can be 1 only, 2 only, 1 and 2, 1 and 3, or all three. So the first thing you want to do is start diagramming out the situation. Basically what we have is a large square, a large wooden square, with a small brass square in the center. I represent the brass square with small black shaded area, and we'll shade this outer space, which I'll call the negative space, in red, and that's essentially the wooden strip that is created with the brass square inlet or set into the wooden square. And we know that this inner square space to the red negative space is in relationship or proportion 25 to 39. And what that tells us then is we can add 25 and 39 and recognize that the small square in proportion to the large square is in a very handy 25 to 64 relationship. So you might recognize that those are both perfect squares, and since we're dealing with squares, we could imagine that the sides of the small square are 5 by 5 and the sides of the larger square are 8 by 8, which is really handy because right away we can see that the width of the wooden strip, which is what the exercise is really asking about, in this particular case, would be 1.5. Okay? Now, recognize that, however, the exercise says these are in this proportion, which means that it doesn't need to be specifically 25 and 64 inches square, but the sides essentially will be in the proportion 5 to 8. Or 8 to 5, depending on if you're thinking little to big or big to little. Now, there is an algebraic solution to this exercise, but I want to first show you how I think of something like this intuitively, because the more you can do GMAT exercises intuitively and cut out the algebra, the faster you can actually get these things done. So we know the side lengths of these two squares are in a 5 to 8 relationship. Great. But we don't know that they specifically are 5 and 8, nor does the exercise restrict them to having to be integer values. So they could basically be anything. So what I like to do is let's draw two more situations which hold the 8 to 5 or 5 to 8 proportion, but with different numbers. First, I'm going to double everything. Okay? If we double everything, we end up with a large square and a small square again, with now side lengths 16 and 10. Now in that case, I'm observing what my width is, and I will recognize that in that case my width, because this is 10 and this is 16, the difference is 6 divided into these two parts, so my width is now 3. And lo and behold, that's one of the choices in the exercise. 3 is one of the possibilities that are listed here. So we've just recognized very quickly that 3 is clearly possible because we solved for 3. So here, when our sides were 5 and 8, the width of the strip was 2.5. Here, when we just jumped to 10 and 16, the width is 3. First of all, apologies. When I was saying 2.5, I meant 1.5 for the smaller square, right? It's 1.5. Twice here makes 3, and add the 5. That gives you the larger square side length of 8, okay? So smaller square with 1.5, larger, double it with 3. Now, you might also try to halve it. Let's go and take the original square and let's draw it a little bit smaller. And if we have the sides, we'd have 4 here, and we'd have 2.5 here. Now that difference is 1.5, and we divide that by 2, and the wooden strip width length is 0.75. So if you were doing this exercise real time and had to move quickly, you might notice we've drawn 3 different scenarios with 3 different side relationships, all holding the proportion 8:5, right? Small, medium, large. In this case, we had the output wooden strip width of 0.75, then we had 1.5, then we had 3, and recognize we just jumped to these values. We could have also gone incrementally. Everything in between each of these 3 scenarios also will hold, as long as the 8:5 relationship holds, right? They'll just be fractional values for the side length. There's nothing wrong with that. So you might now sit back and recognize that if we tried every single possible square relationship between here and here, at some point the width would cross 1, which is one of our choices, right? The choices we're trying to analyze of possibilities are 1, 3, and 4. So as we move from here to here, we will cross a scenario where the strip length is 1. Obviously 3, we created it directly in this example, and if we go larger, we should recognize that we should get to the point where 4 can be created by just simply increasing the size of our squares. That alone, if you didn't have a lot of time left, should be enough for you to consider choosing choice E. All 3 possibilities are actually doable. Finally, for those of you who want to see the algebra, and first of all, the official guide does have a reasonable algebraic explanation, so I encourage you to go to the book and read that as well. But let me just quickly show you my version here. So if we were to use algebra, we could denote, we'll just pick any of the squares. I'll pick the larger one since it's the easiest to see. We could denote the larger side, essentially the wooden side, length x. We can denote the smaller square or the brass side as length y. And we could denote the wooden strip area between the brass and the end of the wood as length w. So from this, we know a couple of very important things. We know the ratio of the sides, the small square to the large square, are 8:5, right, from the previous work. So we know, essentially, that x over y equals 8:5. And from that, we can solve for x, which equals 8/5 y. Or y equals 5/8 x. We also know that x equals y plus 2w, right? X equals y plus 2w. And finally, if we use substitution, we could end up with the following equation. W equals 3 over 16x. So let's stop right here. We have an equation where W, the width of the wooden strip, is in proportion to the larger side length. W equals 3/16 x. Now the question was, which of the following three could be widths of the wooden strip? 1, 3, or 4. And the fact of the matter is, if we plug in 1, 3, or 4 in place of W, we will get some value of x. It won't be an integer value, perhaps, but we will get some value. So in summary, all those values shown, 1, 3, and 4, are possible widths for the wooden strip. In fact, you can come up with any value for that matter for the wooden strip. You would just get different values for the wooden square and the brass square. Hope that was helpful. I showed you a practical solution as well as the algebraic alternative. And I've got more exercises like this on my YouTube channel, so please head over there if you want to see some other explanations to GMAT exercises, or follow my Facebook page, NoBrainer Test Prep. And keep at it, keep working, and all these exercises will eventually become a no-brainer. Till next time, see ya.